Okay, so we'll talk about serverless computing today. So that's the topic that we're given. My idea is I just want to tell you what it is, like from exactly what is serverless computing, or and give you some examples. But then I would also want to talk about the benefits and drawbacks, then give you some use cases, and then, if time permits, show you a small thing, a small function, very simple function, which will just print out your name or something on those lines, and show you how it works, right? So what exactly do we know about serverless computing? Oops.
You're asking us or you're
Yes. Have you heard of the tagline? The tagline, focus on your application and not the infrastructure. Have you, what else have you guys heard about serverless? Oh yeah, this is going to be like a sort of interactive session, but what my plan is I'll walk you through a slide and at the end I'll ask you a question, or when I'm ready, I'll ask you a question, or and that point of time you can, the floor is open to questions, right? So give me a brief idea. So this, when somebody says serverless, the first thing that comes to my mind is there's a saying that says focus on the application, not on the infrastructure. Um, Have you heard any catchy phrases or anything about serverless computing or serverless?
when people say talk about serverless, I feel that okay, the application guys have become too selfish and they don't want the infrastructure guys to have any job.
Correct. That that's a good way of putting it. Actually, that's on one of my decks. I've actually got that. I've actually got that as one of the reasons for serverless, the
Selfish guys.
benefits of serverless. The selfish, not the I didn't mention selfish. I just mentioned the other part though. But so exactly, so then the question comes as to what exactly is serverless. So is it just an industry buzzword, uh, or is it something that's a buzzword because of all the way the cloud vendors have been hyping this architecture? Like, is it just like how Sri just said, um, okay, forget about the infrastructure, or like how I said in the first slide, it's all about the application. Forget about the infrastructure. Do you think it's just marketing hype by the different cloud vendors, be it Google or Amazon or Azure? So what I'll do is I'll take you to the next slide. It'll tell you what exactly is serverless computing from Wikipedia. Now I'll give you a few seconds to read this, but as you're doing that, I just want to say, if you think about serverless computing, um, just think about it in terms of server management and capacity planning. So that's, it's actually hidden from the developer. See, if I was a developer, or if and I'm writing some code, I don't need to worry about the actual code, the actual server itself where the code is being deployed. I don't need to worry about the capacity. For me, that's all managed by the cloud vendor, and they would scale up or scale down or scale out depending on how much the performance is required or how much is the requirement of that service. I just configure it on the portal, and that's it. Um, so to simply put it, what it means is it's just an abstraction of servers, infrastructure, and operating system. Okay. So now I've given you quite a few words, and I've shown you a Wikipedia definition. I've showed you a tagline. Um, are you still confused about serverless computing, or does it make sense? Did anything what I say it will now make sense? Like, or when you read the definition from Wikipedia, or when I explained it in different words, are you still confused about serverless computing? That was a question. That's actually
Actually,
No, no,
some
it's
part
clear
if I
for
can.
me.
Yeah.
sorry. Who was that?
This
Hi,
is
Abhi, this
Jeevan
is
here.
Nimisha.
Yeah. Hi, Nimisha. And
Abhi, this is Jeevan. So what I think is like we don't have to worry about the storage or where it is going. Okay, we
no,
just or
correct. That's correct. You've got
yeah.
that part of it right. So you don't have to worry about the
What
actual.
actual the computing is, it's just like if we have some like an images or something, and if we want to upload it, trigger will function will trigger that, and then the images will be uploaded based on the function when we execute that.
Yes. So you don't have to worry about the infrastructure as such, but but you can't write it off completely either. So if I was to go through a different, now I'll just take you to a visual diagram. Some of y'all might get this, and I'm hoping that that will answer the questions. But then don't complain that there's been too many slides. Okay, I tried to keep it less, and I realized I needed to put in more slides. So this is going to be a death by slide presentation. So if I was to take this and to add on to go on from where you were talking about, Jeevan. So this is if I'm taking of an application like those stuff that we're doing at Centrica. You've got IaaS machines, you've got your provisioning machines, infrastructure as a service. You've got actual VMs where we have to, even though the vendor manages the networking, the storage, servers, and virtualization part of it, we have to actually provision those machines. When I say the vendor manages it, they take care of providing high availability as long as you configure it correctly. But once you get that vanilla compute instance, you can then have control over what type of operating system you put or what type of runtime you have installed on there. And your application, it depends on your application. So some applications would need .NET 2.0, some 4.0. So that runtime is installed. That's you as a end user, like a developer would install, or um, it's because it's your it's the stuff that your application requires to run. But if you were to take this to the next level, like platform as a service, which is the next offering from a cloud vendor, where the only difference between the two stacks is you would have noticed that the vendor's responsibility has now increased. What does this mean in terms of you deploying code? So if I was to deploy an MVC website as a web app, I would write the code on my machine. I can actually build the code like the solution on my desktop or my laptop on my device, and I can then publish it to a web app. So I would initially configure the web app and say, look, I'm writing a .NET application. My .NET application requires .NET Runtime 4.0, and that's what I configure on the portal, and I publish this code. So yes, the runtime is now managed by the vendor, because if you notice now I'm not installing anything. All I've done is from a drop down, I've chosen 4.0. I've not chosen 2.0, or I've not chosen the Java runtime environment. It's just a selection from the portal, and everything is managed by the vendor. The benefit of this is also that it gives you more control because the vendor manages the infrastructure. It's easy to scale up and scale out. Um, so, but then again, your application needs to be smart enough to deal with it. So when I'm making it sound very simplistic when I say that the vendor is going to scale up and scale out. But if your application is like, say, a stateful application, you need to manage your sessions well so that when it scales out, it doesn't create disconnected sessions, if that makes sense, right? Are we all clear with the first two stacks and so far, right? Because the next one I'm going to take you through is how serverless looks like. So do you have any questions so far with the way the environment is, the difference between IaaS, BaaS? I'm just asking. I know most of us know it, but there's some people on the call. In case you want to ask about it, we can stop here for a second. Um,
Yeah, because Jeevan asked that question, maybe Jeevan can say, Jeevan, you understood the difference between IaaS and BaaS, right?
Yeah. So I understood the difference. Okay, what serverless computing I think is, it's more about triggering functions so that it can use the actual what we can say, the compute.
okay. Yes, spot on
I'm guessing that, okay, AB will go on into details of it, but difference between IaaS and BaaS is clear, right, Jeevan?
Yeah.
Yeah, and he was, so that's good. So that we are on the same page. So everyone knows the difference. And like Jeevan said, he was spot on with the functionless part of it, because if you think of the previous stack, the previous screen, and this one, I've now taken out only the applications, the grayed out bit. If you think of serverless, or aka serverless computing, or aka backend as a service, and that's the BaaS part of it. In that application, it's not just the code. There's something to do with the logic. There's something to do with the triggers. Um, so you'll have your own code on there. So that's your serverless function. For example, if you to think of it in Azure's term, or a Lambda, or cloud functions in Google world, in Google Cloud Platform. That's the actual code. But for that code, if it's now dormant. In order to trigger that code, you would need to have some logic or some trigger on it. And the reason being, if you compare this with So what is the difference between function and a platform as a service? If you think of platform as a service, and I said I'm deploying a web app, right? So there is actually on a physical machine somewhere, this site is hosted on there. So there's IIS, something is already serving traffic and is ready and listening. It's just waiting for you to hit the endpoint. But on the other hand, with functions or with serverless code, the code is there and something needs to trigger it to wake it up. So let me just take you through the different offerings. What I wanted to point to you is the functions is the actual serverless part of Azure. Azure Functions is a serverless compute service that enables you to run code on demand, and you don't have to provision any environment. So what you were talking about so far was just the functions, or the equivalent of that in AWS is Lambda, and in Google Cloud Platform it's called Cloud Functions. So these icons, just remember these icons. And when in the previous slide when I said you needed to have like a trigger, that's Logic Apps is more of your you don't have to use it with your function, but if you use it with your function, you can actually create workflows. You can say if a certain activity happens, call function A or function B. So that just sort of like how this branch is showing you. It's basically a workflow setup. It's not, I made it sound very simple, but you can actually set up quite complex workflows in the Logic Apps, and it's quite scalable. Then you've got event grid. So if you've got one input, like say for example, like the example you gave me initially, Jeevan, where you said uploading a photo. So when you say if you upload a photo, think of it that the photo is being uploaded by some end user into a storage bucket or onto a website. Actually, what's happening is that website then stores it. Previously, it would have been a database as a blob, the blob data type, but now people would maybe just dump it into a storage bucket and then add a reference to the database, right? So that's another way of doing it. So the minute that file actually hits the storage account, you can have these event grids looking at the data sources. It could be anything. It could be a database. It could be a storage bucket. As soon as there's a change in that data source, it can then fire off multiple things. Like so, that's the reason why they've got these different arms. But it's basically event grid is a way to connect your data sources and event handlers. So think of it that way. Like I said before, you don't have to use all of these with your functions. It's just the additional functionality that Azure gives you. So are we good till here? So getting an understanding of what functions is, what's the difference between backend as a service, platform as a service, IaaS. Because what I'm going to do next is I'll just walk you through the benefits and drawbacks of each. But unless we understand, unless all of us are on the same page on what the different components do and how they work, the benefits and drawbacks won't make any sense. So are we good so far, everyone?
AB, I didn't understand event grid much. Logic apps was logical, but event grid, what you're saying is that the triggering of the code will be, if you put this code in the event grid, then this, based on a state of an event, I can trigger a code, is it? Is that what you're trying to say? Like
No,
something,
even,
yes, sir.
no, go on. Finish what you're saying.
No, I was saying that something says that, okay, the state of this thing is on, and if the state changes to off, then trigger a code. If I have such a requirement, then I can put it in the event grid. Is that what you're trying to say?
No, I'm saying it's just a connector. It acts as a connector between. So if you say, how can I put that? Um, if you would talk about a publish subscribe type of model, right? So somebody's putting a file into a storage account, and from there you want to trigger a function. So as soon as sort of like how you had, what was it? In old days, we used to have these file watches sort of things, right? If a file has changed, send me an update sort of thing. So it's not the actual code; it's just connecting you. It's just it's like a routing service or something on those lines. Um, but we won't be using it on this in this session sort of thing. If that makes sense. It's going to help you if you want to trigger your Azure function using some event. You would link it up with the event service, event grid.
Got it. Yeah.
Okay. Anything else?
No, from an AWS perspective, then how about S3? S3 should be an one of the component for us, right? Because you only mentioned Lambda. That's why I asked
No, S3 is the S3 bucket, right? You're talking about the S3
you.
bucket.
Yeah, yeah.
Okay, now S3 bucket is your equivalent of your storage account. So like Sri, just to clarify what I just said, like one use case is like, if remember I was saying the publish subscribe type of thing. So in the whether it's Lambda or whether it's Azure Functions, you've got a, and I was saying if a file is dropped in your blob storage, now that event grid will connect as a source. Say my source is a blob storage, or my source is a data base, or my source is something, and it'll pass that message on to the destination, which is whoever is. So like my Azure function will be saying, hey event grid, if there's any change to blob storage A or S3 bucket 1, please let me know because I need to do some job. Does that make sense, Reno? What that event grid does? So it's sort of connecting your data sources with a target. So it's not smart like that. It's more of
Is it, Abby, sorry to interrupt, is it like an event driven means if an event occurs, then only this function will be triggered?
yes, yeah. You need
Let's
to
say,
have
yeah, let's say if we have, let's say if we have an event which has occurred during when we transfer a file or something, then that is where the event driven comes in, right?
yes. It's like a message. It's waiting for a
Yeah.
message to happen, and only if that message comes in will it then do something with that message. Now, where you'd put in the logic apps is some photo has come into the. Um, I'm just randomly thinking up the top of my head. That's why it's taking a few seconds. So a photo has come into the storage bucket, right? And then you can have, rather than just trigger off Azure function, you can then send it down the workflow using logic app saying, okay, if the photo is is quite complex, like it's got different characters into it, like you've got AI cognitive services, right, which can analyze a photo. You can say send it down the cognitive services road, see if it's got anything profane in it, if it's got any profanity or anything that's not good to display to anyone, uh, then send it down a different route. So it'll go down the function and then get deleted. You'd have a function that then deletes it from the storage bucket so that nobody sees it. But for that to happen, it goes via the event grid through the logic flow, which has a workflow which says check if this is suitable for public viewing or not, and if not, remove it. If it is, then maybe resize it to become a smaller picture, which can be displayed on my web page. And if somebody clicks on the thumbnail, then they get the bigger image. Does that sort of work for you guys? Like an example of where you'd use all these three together?
Yeah, I understood it pretty well.
Yeah. I also understood, Abby. Thank you.
Okay, so I'll move on to the benefits and oops, what is I'm going to move on to the benefits and drawbacks, and
Yeah,
we'll first start
before
off
you
with
go there, Ravi,
yes,
in the previous slide, I have a question. See, you explained that, if you can go back to the previous slide.
sure,
Yeah, so you explained functions, logic apps, and event grid in Azure, right? So
yes.
now, if I ask why, if Azure says that okay, there is a use case for logic apps and event grid, why wouldn't AWS think about something similar to that?
Okay,
Why are
so
they doing so? I'm guessing that Lambda is equivalent to functions, and cloud functions are equivalent to Lambda. Now, why does Azure have two services, additional services, and AWS and GCP doesn't have it? And then how are
okay,
they handling such a scenario?
fine. So I just did a bit on GCP recently, so I can tell you about GCP. The whole idea of this slide was to mainly focus on functions. And when I was going through functions, I saw logic apps and event grid. And to myself, I was just thinking, how will I use a function? So I added stuff on there. I didn't add, because this whole topic is about functions. If serverless computing was mainly about functions, it was not about logic apps and event grid. That because you guys asked me questions, I had to think about an example where I would use it. But the equivalent in GCP, I would think, is the Cloud Pub Sub. If I'm, it's called Cloud Pub Sub, which is like a event viewer. It's a publisher subscriber sort of model. I'm going to guess that that is the thing I would use with Cloud Functions. AWS, I'm not going to even guess because I don't know. But there
So
would surely be
in
something equivalent in AWS.
yeah, Abhi, so in AWS there's something called as AWS step function
Okay.
that can get you the step how you want to do the steps. is almost similar to logical apps,
Fine.
and they have something called as one more thing also for them to do the models to do it up. AWS has a larger umbrella with respect to serverless, if you ask me.
No, then on that I have to disagree, but let's disagree outside this session. Uh, I've
Maybe
got a, yes.
Rajesh.
Okay.
Sorry, I joined late.
Hey,
But
Rajesh.
anyway, so I have a question. How we can say logic apps is a serverless function?
No, it's the functions are the serverless compute option. Okay,
Okay.
I didn't say that logic apps is serverless or event grid is serverless. The main
Okay.
topic here is functions. The only reason, I should not put this on at all in the first place. The only reason I put those other 2 points was just to tell you how I would use functions. Like if somebody came and told me, okay, I've got I want to, so somebody's going to upload a photo into a website, and I want to check that photo and resize it so that it's a thumbnail image, and I also want to I want to check and see before I resize it. I want to check and see that it is actually suitable for public viewing, because you could go and upload any random picture. On my website, I want to make sure that only photos suitable for the public are uploaded. So with a function, yes, I can take a photo and resize it. With a function, I can do all of what I said, but then that's making the whole function complicated. And the problem with functions is you've got a time limit to how much it'll run. It's got a set time limit. You can't run more than that. So
No,
the
you
only
can set that. That is basically configurable, right?
yeah, but there's a limit, right? There's upper limit. If I was not mistaken, 10 minutes or 20 minutes or something, 10 minutes or something like that. I'll have to check. I've got it on the slide. I can't remember off the top of my head.
Yeah.
But then that's why you'd use logic apps and event grid. So the event grid will connect with the storage bucket where the photo gets lands in, and then using the logic apps, which is just a workflow definition, I would route
Yeah,
it to the
it is equal to the BizTalk service, which is in an on-premise solution, right? So integration service.
yes. That okay. So that's information for me. So I would
Yeah.
know that.
I think so. Logic app does not have any written code.
No, it's an integration service. You just get something and just
Yeah.
pass it on, right? That's it.
Correct, right. It's like a workflow which usually flows everything.
That's right.
Yeah.
And event grid is mainly for just sending the events, right? Or receiving the events.
Yeah, like a publisher model. So it is just going to send the events, and then it will connect to different data sources. So in this case, one of the data,
Yeah, both publishers and subscribers, right?
yeah,
Both.
both of them.
Yeah. Sorry, Abhi. Go ahead.
No, that's fine. That's fine. So shall we move on to the next benefits and drawbacks?
Just while you both were talking, I did a Googling.
Yes.
Googling says something different about Logic Apps. Okay, Logic App, it says that Azure understands a lot of applications like BizTalk, EDL, those kind of applications. So if you want to integrate between applications, instead of you creating the integrators, Azure already has a lot of integrators, which is called as Logic Apps, so you can integrate it. That's what I understood from Logic Apps.
No, Sri, Logic Apps is mainly a kind of a replacement for BizTalk, right? Which we use in the on-premises world, right?
Messaging system.
So Logic Apps do have some kind of out of the box, right? If you want to set up a kind of a process flow, like when you get an email, please tweet it, right, in the Twitter and all, right? They already have a kind of API readily available, right?
But
that is where it's a.
But that's more like a queuing mechanism, right? If this kind of message comes, send it here. If this kind of message comes, send it somewhere
No,
else.
it's an integration. It's an integration platform actually.
It's integrated with SaaS.
It integrates multiple services, right? It's not really SaaS, right?
Okay.
But you can visually also on the Logic Apps, you can set a flow of how you want things to work.
Absolutely. Basically, you can send this to functions as well, right? You receive some email, you can just configure your Logic Apps to get something. For example, you get an email, right? You can send that to your Azure functions to process that.
So to set the context right, that was the only reason why I mentioned it. I would the only point that should actually be on the slide is functions, Lambda, and cloud functions. Logic
Okay, when I joined, I saw this Microsoft Azure, right? So that's why the question I said, sorry.
No, that's fine. That's fine. So I'll go to the benefits and drawbacks. What we just we're talking so far was about IaaS, PaaS, BaaS, Backend as a service. And I'm going to now take you through the benefits. Now, the benefits first, and then I'll take you through the drawbacks. Um, and I've clubbed them into three different columns. One is from a business perspective. This is developer perspective and user perspective. That's thanks to Harsha's feedback last time where he was saying, what is the use of it from a business perspective? Okay, fine, great. So here it is from business perspective. You can see it's improves the process of code deployment. So if I was in a development team, I would have my stand-ups. Agile is the thing now, is the buzzword now. But if you look at different companies, Shazam and all, for example, they came and said they were big Agile fans. So what they do is they have different stories. So today the market requirement is we need to get something out. Like tomorrow there's going to be a big show. They want to release some ads or something very quickly. Instead of going down the waterfall model, they build in small pieces of code, which they can then quickly release to the market. Basically, from business perspective, I know what my customer wants by doing some studies, and I can quickly release something out to the market. That's what I mean by process agility. And by cost, what I mean is, if you remember, we are deploying code, only code. We're not bothering about the function, about the actual infrastructure. So this comes to your first point, Sri, where you were saying, okay, the new developers are just being selfish and not bothering about having to depend on infra. Yeah, so the cost here, and if you remember, I said I'm going to mention this later in one of my points, right? The cost here is actually the cost saved by not having to hire so many back-end infrastructure engineers. Sorry, but sort of links with what you said initially. So it is not selfish, it's just one of the business perspectives, one of the drivers behind this. From a developer perspective, if I'm a developer and previously I would have to install IIS or install the .NET runtime, and I have to make sure that the code really works. So the guys who are doing the migration right now at Centrica know the pain behind this of having to set things up and getting things wrong. But if your code is written really well, all you do is you just deploy a code onto a web app, onto a Lambda function, and there it is. It's there ready for you to do. So from a developer perspective, the developer doesn't have to worry about any system administration. It's there, it's set up quickly. Now I'm making this look very simplistic, but if you think of it at a high level, that's how it works. I'm not saying that forget about network, about security. All that should be there, and that is part of a good design. But from a perspective of having to spin up a machine or spin up a VM to just deploy a code, that's all out of the question. Now, what do I mean by scalable? By scalable, I mean by making it, in order for your code to work as a function, you need to write the code in such a way that it's scalable. When I say scalable, it needs to be, think of microservices. So that leads on to the next point as well, like the use of microservices or service-oriented architecture, where things are connected, but it's not tightly coupled with sessions and all this. So your session would be outsourced to a like Redis cache, or previously it used to be Memcache. When you're on premises, you'd share Memcache over a IaaS web farm. But when you're going to the Azure world, the cloud world, you'd have a Redis cache, for example, which is outside of your application, or you'd store your session in the database. Uh, but that lets your code become scalable, which means tomorrow if you were to scale out your function or your into multiple functions. So let's go back to the first example where I said a photo is being uploaded to a storage bucket, right? And you've got a function that's checking the photo and making it a thumbnail image. Let's keep it very simple. So it picks up the photo and reduces the size. So it's a much more smaller image, which is then picked up by the website somewhere and saying, okay, from this folder, go and show it. Now, what happens if it becomes very famous and then people are just uploading pictures randomly, quite fast, and it's happening too fast? So instead of having just one function, because your code is written in a way that's scalable, it can just spin up. You can have multiple functions running at the same time, doing the same job, right? So that's from a developer perspective. From a user perspective, like I said, it sort of ties up with the first, process agility, because those are coupled to each other. Because if the customer wants new features faster, it requires process agility and vice versa. So, and then there's a better user experience, because now say if you might have noticed this, like when new apps come on the Android store, I'm talking about Android store, Apple Store or Android Store, you'd see that some of them have bad feedback, like some apps have really bad feedback, and then the developers then reply back saying, look, we've released a new feature. It's the new updated version, please update to it, and you'll get the bugs that you have found have been fixed in it. So that iterative process, the user gives some feedback, and then the business gets the requirement, the business analyst gets the requirement, the developer builds the code, deploys it, and leads to better user experience. So that's what I was talking about by benefits. I'll move on to the, are we happy with this, with these 3 points? Yep. I'll just go on to the drawbacks then. So if I was to go to the drawbacks, the eagle eye among you would have noticed that one point or something was same in there, but I'll leave it for you to come to it. But let's go back to the business perspective.
One question, Abhi. Am I audible? Hi, this is Nimisha.
Yes, you are. Hi.
Just wondering whether you get to write your own Lambda code. Can you customize those, or we have to use the pre-doled out services that AWS provides through Lambda or Microsoft provides to functions?
No, it's the wrapper that's provided by the vendor. So the ability to write the code, the actual code is your code. It's what you put in there. So you can start off with an example that they give, but then it's left to you to write the code that you want. They just give you the, if you think of it from a bigger, they just give you the wrapper. They give you the envelope. You put the stuff in it and use it. Does that make sense? Like a letter envelope thing. So the envelope is what the function is, and how you use it or what you fill it in, whether it's cash or paper or anything, that's up to you.
No, I understand that there would be variables, there would be parameters that we would have to feed in. But function is basically a typical service that AWS is providing out of the box. So just wondering if a developer has that kind of freedom to define a Lambda functionality by himself.
Yes, they do have. They have full control over what goes into the code. So the same, you could write different functions. So Azure gives you functions, right? So one function could be look at this photo and resize it to become a smaller photo. The other function could be there are hundreds of photos in this storage bucket. Delete anything that's older than 5 days. So for both these features, you're using functions. One is doing a resizing task. The other one is doing a archival clean sort of task, but that's actual code written by the developer.
Okay.
So this is why the developer would, this is why the developer would like it, because they have full control over it. Now the problem when you give, I was going to start with business perspective, but now since Nimisha asked the question, I'll start off with the middle stack. The problem with giving developers too much control is you can end up with having code that's sprawled all over the place. Now, if you remember when I said before, the whole point of this functions, the benefit was scalability. Now, how you achieve scalability is by you going, say, for example, the microservices route. You've got this big application. You've said, okay, let me cut it up into small chunks. And the problem is if there's no single thread between the different chunks, your chunk will work perfectly well. But when you bring it together, all the pieces together, they might not work. Or there'll be some bugs and it'll be quite difficult for you to actually find out where the bug is. So that's what I mean by architectural complexity. So it needs to be developed and designed well, and the thread should be, there should be a sort of seamless thread, let me put it that way. So it's not connected, but there is a logical flow that connects everything together. The execution duration that I was referring to before is capped, and I've got the exact numbers. I just made a note to myself. The exact number is 5 minutes. On a default timeout for functions on a consumption plan is 5 minutes, and it can be increased to a maximum of 10 minutes. So not 20 minutes as I originally mentioned a few slides before, it was 10 minutes. So that's the maximum time you have for a function. So that is your limit, Nimisha. So you can write whatever code you want, as long as it's, if you're choosing a consumption plan, you need to choose the right type of plan. If you choose the wrong plan, you have only 5 minutes to execute your code. So it should be small chunks of code. That's the whole point of the serverless component.
Okay.
Then what else? I think Rajesh had enough sales left. Okay, so let's go back to the business perspective. So from the business perspective, what did I mean by reduced overall control? So this again ties up with what Nimisha and Sri was talking about before. So we are talking about functions in Azure or lambdas in AWS. Now, by us telling using one of those capabilities like Azure functions or lambdas, you're now tied to that vendor. You can't port your code across to a different vendor from Azure. Yes, okay. You can't lift your code exactly as it is because the way it's written in AWS would be slightly different from the way it's handled in a different cloud vendor. Okay, now I can't give you more details on that because I've not worked on a Lambda yet, but I've had a look at cloud functions and Azure functions, and it's tied to the runtime it works on, whether the runtime is actually supported in the different vendors. So you'll have all those things that you need to think about because in a way you're tied up to a vendor now. But then in the bigger picture, usually an organization goes with a cloud vendor and they decide to stick with them for some time. So you would have that. So is it a big problem? Yes, you are tied to a vendor, but it's not that much of a big problem when you look at it from the bigger picture. There's a risk because these functions and everything, like I'll send you a link. What I did is I just created um, a dummy function based on some sample code, Nimisha, that is available from the function. So that is not code that I wrote. I just changed it slightly just to show your name or something in the error message, in the log that in the log message, not the error message, the log message. That is only customization I did. So that is a sample message.
Abby,
yes.
Are you planning to do any demo today?
Just a small one, not a very major one. It all depends on the time. I'm going to speed through the rest of it. Don't worry. So that's where the risk is because then it's open to everyone. That's the problem with not just functions, it's the problem even with platform as a service as well. So unless you put an API gateway or something in front of it, there's no way to restrict access to your function. So that's your risk over there. And poor user experience is what I was talking about before, which links to this complexity. If it's not designed well, you won't have a good experience. Now, I want to take you through some use cases so that you get an idea of where you would use it.
Before you go to use case, so I think one more other drawback which I think is that debugging. So
yeah.
How do you test locally?
That's correct.
And how do you monitor it? How do you monitor how the function works? I don't think CloudFormation or a CloudWatch don't have a
correct.
monitoring.
You're spot on that part. That's part of the architectural complexities because you can write separate components, and this is what I was saying before. If it doesn't tie up together properly, then you won't be able to. It's very hard to find out where the problem is. Then your second point about getting logging. So the functions have some logging by itself, but the minute you close your portal and come back to it again, you lose track of all the previous logs. So the only way to do that is you have to maybe push it to a different, maybe to a storage bucket or to a database or something like that. But then it's a bit of a pain. Yes. So it is quite hard. I agree with you.
Maybe a few questions. If I write a code, if I write a bad piece of code, right now because I'm putting my code onto a server, the worst that could happen is the server will crash. It will go to 100% CPU or 100% memory, and it will crash.
Yeah.
But so I'm not. There is no infinite loop of usage of resources. But when I put a bad piece of code in the Azure function or any of the serverless computing, does it provide me with infinite amount of compute, or is it there is a limit to it?
No, you would configure it to have a limit, to a high limit and low limit, but then you can also see it in your logs. So before you deploy something to, when I say it's a function, you can actually develop the code on your local machine, right? You would develop the code like a console application or something, see how it works, and then you deploy it to into a function, into an Azure function. Now, say that when you deployed it, you made a mistake. You can put limits on that to make sure that it doesn't scale out. So that's one way. And then you would have maybe say put app insights, for example, to look at your performance, or you could look at the resource monitor, the logs of the actual application to see if any errors are being thrown. And that's the only way to monitor it, to see if it's doing the thing that you expect it to do.
Okay. And you said once somebody writes a code into this, anybody can see it, or did I understood it incorrectly?
Not anyone can see it, anyone can access it. So, and that will come.
Can't we put any RBAC or something to say that this Azure function is visible only to the set of group of people or something like that?
You can put a session. You can, yeah. It'll have a subscription key. That's what I'm saying. So you can put a key or something on it, which will let you hit that function and let you get in. But then you can be DDoSed by it, right? So if somebody keeps on slamming it with the wrong key, your function is actually running and you're getting charged for something that you don't have to be charged for. So the best way to do that would be put a gateway in front of it. I don't know what the equivalent is in AWS. Rajesh, correct me what it is, but or Sri, but in Azure it's API gateway, and in API gateway you can expose an endpoint and connect it to your function at the background or an BaaS service, and then say only people with a certain key can come in. And because it's software as a service, it'll handle the DDoS side of things. And you don't, because if you think of it, functions, you're charged every time it runs. And one of the drawbacks of this method is you don't know how much your cost is going to be, just because of the fact is you don't know how many times this function is going to be called. Does that make sense? I'll show you the example in the end, and then you'll understand what I meant by anyone can access the function.
Sure.
Okay.
Sure. And so, as a developer, do you think that anybody will need a server going forward?
Yes. As a developer, I would still. For legacy applications, yes, you will need it.
What I'm thinking is, if I have a Azure function and it's Azure storage and Azure SQL, without I can get away with the need of a VM, right? Code is running, I have a database, and I have a storage. Will that work?
That can work because you can have it was, but then you'll have to use just not functions alone. Functions is just like I said, it's got a cap, right? 5 minutes or 10 minutes. I would use functions, and I would also go for web APIs, API calls. So the API would be stateless. It will do some action, and then the function can call that API. So sort of like a distributed way of working. It's going to be very hard to tie things all up. So when you design the application, you need to make sure that you're designing it right for all use cases, but it'll be scalable. So yes, the way, if you to start from scratch, it is a way to design how your applications. Yes, you can go serverless completely, but not just using only functions. You'd have to use functions, you'd have to use web APIs, but it can be done, yes. But when you get to be more complex, and if you're using third-party integrations, if they don't support going serverless, then yes, you would need a machine for it. But most of the people, like if you think of it, even a few months ago, nobody was thinking of SQL Server analysis services going onto the cloud. But now slowly that's also coming onto the cloud. So over a period of time, yes, everyone will come over to serverless. It's in the best interest of the vendor. Just think of it. If I'm Microsoft and I'm pushing for serverless, it means that you're now locked with me as a vendor. You're now locked with Azure for some time, for the near future. So I'm making money every time your function runs. I'm getting money anyway, whether it's a error or it's a actual, whether your code actually does something useful or not. The minute it runs, you're charged for the time it runs. So it's in the best case, it's in the best interest of the vendor.
Got it.
Yeah.
Thank you.
So I'm going to use cases. I've just picked up 2 use cases alone. My God, time just flies. I thought I'd be short of time. It's taken longer. So let's go through it quickly. So there's one example is I want to talk about a message-driven application. This is like your common application where a user has a lot of backend data processing as well. So in terms of Centrica, let's just think about the short-term planning application. You've got a star operator at Centrica. One of the among star operators, they come onto this short-term planning website. They submit a ticket. And by them submitting a ticket, what happens is there's the code that's there, your monolithic piece of code, your .NET code is running in 2.0 or whatever, some runtime. It's picked up the ticket submission, it processes the ticket, and then stores it in the short-term planning database. Now from there, it goes on to the downstream system like Vimis or whatever, or Taskforce, right? So that's the traditional way of how a site works. Now, if I was to think about this in terms of serverless, like say if I was to convert this application or try to move this into a serverless sort of way, this is how it will look. I've now removed the ticket processor part of that code onto a serverless function. This comes back to your previous question, Sri, like will you get rid of the code completely? But if you think of it, this ticket submission part is still part of the monolithic code. So there's different design patterns you can use to change away. One of them is called scaffolding, where you're now extracting from this big piece of code the actual application, the STP application, which has got UI, some business logic for ticket submission, business logic for ticket processor. I've now removed from there the ticket processing code and put a ticket processor function. So what it does is, as soon as that function sees that a ticket has been submitted, it'll then process it, do whatever that processing job was doing, and then store it in the database, right? So that's how.
And you can. Maybe are you saying that I cannot put a HTML page or a dynamic HTML page as a function? Because the ticket submission is going to be a HTML page which is creating a JSON file or some kind of XML, right? Are you saying that those kind of use cases will not work here?
No, but no, it will work, because that's what I was saying. You'd go for platform as a service. So in that case, you'd use a web app. So not a web API. Web API is just the from your web app. Yeah. So the web app will still be serverless. That'll be platform as a service, and then you'll have your functions running in the background. So that's backend as a service. So yes, it can go serverless, but that is a scenario. And then, so if you saw here, I've now got a ticket processor function, which now stores in the database. And tomorrow, if the load gets a bit too much, sort of like how I was talking about your previous Instagram sort of example, where people upload a lot of pictures, if there's more tickets coming in, you'll have multiple functions which will then scale out. And as far as the user is concerned, he submits loads of tickets, but he's still happy because his system is working. It's now gone into a queue. Maybe that's where you'd use your event grid. As soon as a ticket comes in, it then says queues it up and then sends it down to a function that's ready and looking for it. And all the function does is it processes the ticket, stores in the database. So that's a very simplistic example of a message-driven application, right? Okay, I'm going to the anyway. Any questions on that? So I think we're okay to move on to the next one. Silence. Great. I'll move on to the next one. Perfect. Let's talk about UI-driven applications. So in this, what I'd like you to do is think about this I've basically nicked from a website. Think about a three-tier application. You've got a browser, you've got the actual code, and you've got your database. Now this is like your Chrome or IE or any kind of browser. You've gone visited a website to do some kind of action, be it purchase or whatever you want to do something. And if I was to replace this pet store application with an API gateway and with functions, now this is what I was talking about, the API gateway protecting your functions. Now what I've done is, this is quite of a it's more of a dumb browser. So when I say dumb, it's not doing anything smart in it. All it's doing is it's going to a website URL, and from there you're saying you're doing a purchase function or placing an order, searching for some product for your cat or dog or something, and then you're buying the food, and that request gets stored in the database. Now when you go into the serverless architecture, this is going to be a bit more complicated, but I've simplified it a bit. So if you've got any questions, stop me at any point in time, okay? Out of this big application, I'm just taking out two applications. There's multiple more functions in there, but for you guys to understand what it's doing now is, you've got now the authentication logic, which is also inside this application. It's moved into a service, so that can be some OAuth authentication. Like say when you go to the browser to the site, it says use Google to sign in. So that's where the OAuth side of things come in. So that's been outsourced out of this pet store application. Now this is not doing any authentication anymore. From a security perspective, that's really good, because now if this database was to get hacked, it doesn't have any user details on it. All those user details are on this third-party guy's website or store. All that you would have in your database would be an identifier linked to that, like a token ID or something linked to that OAuth provider. So there's no user details being compromised in that scenario if your database was to get hacked. But what they've also done here is they've now removed the pet store purchase function and the search function. But the search function, what they've even done better is they've now split this database into two, like keeping a small subset of the products. So in this database, if there were 10 products, now this small database has got 10 products in it. And when I come through the client through the API gateway and I hit my function for searching for a product, it looks in the product database. And then I can then place one more request for making an order, and the order goes into the main database. So from a performance point of view, you can see the difference. Like here in this scenario, if you had hundreds of users searching and only one person trying to buy, and if that slowed down your system, that one person who's going to buy also will be put off, and they say, okay, fine, I'm fed up with this website, let me just go away. But when you move on to this model, this split out model of using functions and a separate database, you've got improved performance because the people can search as much as they want. All the requests go to a different database, and the guy who wants to buy, which is the actual money earner for this company, he gets a good experience. He just makes a purchase and then he goes away happy. And so that's this UI driven type of application. Do we have any questions on that?
The developer in you, I can see that the developer in you is coming out a lot. Maybe we are infrastructure based, we are not so much interested, or at least I.
Okay, fine. So maybe I should hide that more. Okay, so but you get the picture, right? Okay, from an infra point of view, what is it? So from an infra point of view, if I was to look at it, I would have two databases. I'd have functions on there. I'd have to provision the API gateway. But all this can be done through the portal. Like if I was to create a new Azure SQL database, it's all done through the portal. You can also publish it through your Visual Studio. API gateway is software as a service. This is software as a service as well. Backend, there's no VMs created on there. API gateway is what we went through this morning as well, Rajesh, where you actually link it up to different functions. And that link, this requires some code changes because you now have to interact with an external party. But it's quite simple now. Sorry, let me rephrase that. It's not quite simple. It's simplified this version of the code. It's improved the performance by going serverless. But this comes back to Srij's point as to if it's hard now to debug, because if something goes wrong, you need to actually have good logging to find out which component of your system has now failed to throw the error. So that's the minus point with this design. That's only minus point. One of the minus points.
Abhi?
Yes.
So if you go back just to the earlier screen, you wouldn't have two different databases, purchase database. You meant to say purchase table and product table, kind of, because you would split.
I know what you're trying to say. It doesn't make sense when you think of it. Why would I have two databases? It means keeping two databases in sync and all that stuff. Yes, it does make sense from what you're saying, and no as well. If you think of Oracle, like let me take it down the Oracle route. If I was to go down the Oracle route, now SQL Server started supporting that from 2016 onwards, where you could actually read from your replica database. But Oracle always had that before. You would have, correct me if I'm wrong on any Oracle people, your primary database is there, and you also have a replica that's running. But you, as an end user, were allowed to connect using a scan listeners to either the primary database or the secondary database. And usually, what people would do is any write requests would go to the primary database, and anyone who's trying to do reports or anything would be redirected towards the replica database. Now, if you were to take that scenario and apply it on this use case, what I'm now doing is I've now split up the database into two. I've got my, when I call it purchase database, this would be the major chunk of it. Maybe the only part I've removed is some of the information like products, and because we're only talking about search, I've mentioned product database. It's not a table, it's actually a database. One of those tables in the database is the product table, because that's going to be static. When you have a new product, you'd apply, yes, there's a question of manageability. So when you have a new product, what will you do? You'll add it to this database and to the master database as well. But if you look at it from a performance point of view, your search function, now if you have hundreds of users searching for some new product that's come in, you've put in a new deal on your website saying if you buy product X, you'll get 10% discount or 50% discount. You're going to end up having people searching for that product, and you don't want them hitting your main system. They would come through that's the scenario that's been explained here.
So
yeah, go ahead, Sujit. Sorry.
In another way, what you're saying is kind of distributing the load.
It's basically a microservices based, architecture. See, people are moving from a monolithic application to microservices where you can just split the services, and those services will have their own, databases for the scale up and scale down.
Cool. So what you would also do then, probably you will introduce some serverless function to only update it on one product database, for example, that automatically populates for the new products, or any product updates is automatically updates in the purchase database. So you don't have duplicated efforts.
Yeah, so for that I would use a CI/CD pipeline like TeamCity or Jenkins for that, and then I'd have in my CI/CD pipeline I have different tasks. The first task would be okay, look at the database and see the diff, and then publish the changes to the product database, then publish to the purchase database, and then bring it online. So that would be done using CI/CD.
Do we want to
Thank you.
complicate into CI/CD? I mean, as you said, we can use a read replica of the purchase the database only for search. So
Correct. No, that's because if you're using SQL Server 2016, it allows you to, but in the previous cases, it was not letting you do that. But yes, if you want to use your
AWS is providing a read replica for you. I'm not sure it's SQL or Oracle.
Okay.
No, see, it provides for their RDS, right? That can be.
Yeah. Because we're talking about serverless, so I don't think that I'll put a DB on a VM, right? I'll always use a RDS of AWS.
No, it's not mandatory, right? It's not mandatory.
No, so I don't want to manage my DB, right? So I put
Yeah,
it
but
in
then
RDS, so all my DB backups, everything will be serverless for me.
correct. But then what will I do if you have some function, like if you've got some SQL jobs, for example, if you've got some jobs that need to run on the database? For that, you then do need you would need some kind of a task scheduler to connect to your, because if you in Azure SQL, you don't have the capability to have SQL jobs running on the actual Azure SQL database. You would need a different sort of either provision. The cheat code is to provision another VM with SQL Server, have jobs, SQL jobs, which then connect to your Azure SQL database and then update it. Right? That's the sneaky way of doing it. But natively, the Azure SQL database doesn't let you run jobs on it. It doesn't give you that level of granular control. So that's where you would need a VM, for example. That's just a, but we're digressing off quite a lot the topic. But you get the picture, right? Why I would split it, or why in this scenario it's been split out into a database. It's basically the microservices architecture is the shortest answer of putting it. I wanted to deal with the big question, which was the containers and Azure functions. First things first, just want to make everyone clear that I've not worked with containers yet, but I can get you a brief idea of what containers is. Because if you think of containers and let's first talk, we've been talking so much about Azure functions, and we have a good idea about how Azure functions is right now. But if you think of containers, the idea of containerization basically is you're creating a container that has got all your dependencies pre-installed. You've put your application code, your any runtime that it requires, and it's all there in one container, and you just deploy that container wherever you want, and that code just works. This is especially good with think of any legacy application that you need, which is expecting a particular flavor of, okay, keep hold. Let's say .NET Runtime 2.0. So if you go to Windows Server 2016, for example, it doesn't have .NET 2.0 by default. It has 3.5 and 4 and above, or 4 and above by default. If you need 2.0, you need to install it from the features list. So if you had this container option, on the other hand, you would, when you deploy the container, you have the whole application with all its dependencies and everything readily available. Now, a small history lesson was, I think it just mainly went to popularity when everyone got to know that Gmail was actually a container, and that's when everyone started looking into containers, and then you had some company called .cloud, which then became Docker, and all that stuff happening. So what exactly is containers? Both of them are actually serverless if you think of it from a point of view. I'm just going to click through and see what else I've got here. Now the question is, when would you use containers? I would use containers if I had to move legacy applications like I was doing initially. But if it's something I'm writing from scratch, I would just go with Azure functions. And why is that? it comes back to what I was telling you first about containers. You have to wrap everything up. It's not as simple as Azure Functions. When you write a container, you need to have the operating system, you need to have the runtime, you need to have your code. Um, it sounds very easy and sounds good to use, but then what happens when there's a patch like the WannaCry virus came out? So then you had to patch your operating system. So what do you do then? So that means you have to rebuild everything. You have to rebuild your whole container and then deploy it once again. So there's more administration to it. The costs are there to it. But from a administration point of view, if we were to look at functions, that's much more simpler. But can you run legacy functions on it? No, because it has to be small microservices. So you have to choose about which route you're going down when you're going down the serverless route. So that is all what the slide is. If anyone wants to add anything more about containers, or if they have a different view, please go ahead. We can hear about that.
I think we are already overrunning, so probably you can.
Okay, so let me just go on to this.
Hey, we are not overrunning. Right? There is a demo pending, right?
No, we can.
Yeah, that's your thing. So I want to waste the time.
Abhi is anyway free, so.
What if we free? Okay, fine. Yes. Okay, so I was going to put this slide there saying if there was time, but if everyone is late, we can stop.
Hey, I can wait, man.
Okay,
I want to see the demo.
So what I wanted to say was, so far, how have we been so far? So, so far, how has it been? So what I've been telling you about functions and everything. So all I want you to remember is there are different types of functions. There's different triggers for functions. The simplest one is HTTP request. So if you have a HTTP request, you can make a call to a function. Sri, you were asking me originally, like, how can anyone access the function? And I said, I'll let you know when I have the demo. Now, it's not a very awesomely complex function. It's just a normal function that I have. But what I'd like you to do is I'm going to post a link on WhatsApp. I've actually sent it on WhatsApp to you. But basically what I'd like you to do is I've sent you a link. If you don't select the link straight away, but what I want you to do is at the end of the link, if you look on your phones, at the end of the link, if you can replace, after I've filled it up for you, I've put a ampersand name is equal to, and I'd like you to put your name on that and then hit submit. Sorry, and then just visit it on the browser. Sorry, not hit submit. What am I talking? So I've sent you a link. Can you see this? Can you see that link? Hello?
Yeah, I'm able to.
Okay, so
and it shows the name, hello, and the name.
And it said hello, your name?
Yeah.
Okay, can you try that again, Animesh? Let me just see something.
Yeah.
Okay, and I'm going to try that as well. For some reason, I don't know if I've exceeded my free amount. Clear. My function is running, but I'm supposed to be seeing something here. Why is it not running? Okay, so there's a demo devil happening right now. It's not working. The actual function is working, but I'm supposed to be logging it, so it works over here. So you just paste in your name, maybe from browser, and then it'll show your name. But Sri, if you remember what I told you, if this gets compromised, it's basically running off. So where's my code? Yeah, so the code and all is working. Yeah. Okay, none of this is going to make sense till I actually tell you what I'm doing. Okay. So Sri, you're still online. You're still there, right? No, he's gone.
Yeah, I'm here. I was just trying to make it work. Yeah.
Yeah. So that'll work as long as you in the URL, like I send you the link, right? So at the end where it says name, you need to put your name, and then it'll just spit out your name or whatever you type there. And optimally, what should happen, or what was happening before I called you guys, was I changed the code here to say.
I was trying to replace that word name with my name, but you were asking us name equal to name, right?
Yeah, name equal to name. So you need to put name equal to name, and then it'll say the browser will return back to you what it's actually found. Now, effectively, what's happening behind the screen is I created a function, and most of it's a get function. So that's why when you browse the URL, what's happening in the code is it's some C# code. It came out of the box. What I've changed here though is I've just said I've told it to write out the name in the logs, which is what I was talking about, where it says here it's supposed to show the logs. Srijit, if you remember, you had asked it's very difficult to debug the error. Now this is one scenario like that, where it's actually supposed to say my name, and it was showing that before. Now why it stopped working, I have no clue, and I need to start looking into this in detail to see why it stopped working. And if you see what I've just done, I've refreshed the page, and as a result of that, I've lost my previous logs. You're now connected to streaming logs. Let's see if it works now. Ah, awesome. It looks like it's doing something. Yeah. Okay, fine. Perfect. Guys, can you, so the question was, how did it get to work? I have absolutely no clue. I didn't change any code. So this is one of your prompts. So now see, I've got a message from Srikant, which says he's visited the page and he's typed in the word Srikant. I've got one from Animesh. So if you see, it's just a normal function. It's expecting the trigger is a HTTP call. It's a GET call. So by you visiting this URL and giving in this code, and at the end of the name, you said you have put your name. That's because this piece of code is looking in the query string. It's saying request our query string name. So it's looking for the object name, and in that name is trying to see, okay, what is the value that's passed to the variable name, which in this case is AB1, or like how I was testing before, AB from browser and all that stuff. So it's now copied it, AB from the browser. So it can be whatever you want, and this can keep on running. And every time it runs, I'm being charged for it, or Cognizant is being charged for it in this case. But the point is, you have now hit my function endpoint, which is not in a good. So if I was a customer, I don't want to show this to the client. And this is what I was telling you earlier in the day, Rajesh, that we would want to hide this behind an API gateway, whether it's a Lambda function or it's a Google Cloud function or if it's an Azure function. This is not the URL that you want your end user to see. You have no control over this. This is what Azure gives you out of the box. But what you do have control over is you have an API gateway which you put in front, and then you'd issue a separate. So guys, what I'd like you to do is, if you remove the equal to sign from the code, or just basically change something, you'll get an error. Let me put it this way. Let me go back to my REST client. Sorry, it's taking too long. I'm supposed to end it. I don't even know what the time. Oh, 9:15. Okay. I'm just opening a REST client. When the machine loads, give me 1 second. Okay. So I've got my REST client here. It's just another tool that's attached to Chrome. What I'm doing is I've made a call, and I've got a hello from AB REST client. So if you look in my logs, you'll see AB REST client here. So I've made a call just now, but if you see, if I remove even one letter from here, which is the code, and then make a call, I'm getting a 401 unauthorized. So this is the, so I've not used the correct code. So Sri, when I said that this URL can be accessed by anyone, see, there's only one single code here, and if somebody gets hold of this URL, now if you share this with tomorrow, I've only shared it with few of you on this Born in the Cloud group, but tomorrow if you were to share it with somebody else, and this function is still alive, somebody can access it, and I'll get charged for somebody using this unauthorized access. And when I say unauthorized, it's unauthorized from the. Sorry.
But Avi, this is what you said. You can control it by a key or something. If
Correct.
I send. Oh no, I get what you're saying. If I accidentally expose the key also, then yeah.
Yeah, correct. So now, but the thing is, you have to remember, this key is now sent to you and to everyone else on the group. So I don't know who's hitting me. The only reason I know who's hitting me is because I've told you to put your name on there. Now, if you type, see, we've got Narendra Modi also there. Now, I'm sure that Narendra Modi was not there. Was not.
Hey, don't talk of Modi, okay?
Okay, but he came in and he posted here as well. Fine. So there's no control over it. The only way to control it is if I was to put an API gateway in front, which comes back to my previous slide, which I luckily I didn't realize that I had that before. If I've got a API gateway in front, quite slow. There's an API gateway in front. That API gateway would, wow. The API gateway would have a key associated with it, and that key I would give only to one person. Now in the background you have the code key which the Azure function expects, but the API gateway key will be unique to each user, and by that I can rate limit you. So I can say, okay, Modi can make only 5 calls in a day, sorry, and Sri can make 10 calls per day. So I can limit that at an API gateway level, but not at the function level. If my password here gets compromised, I need to now do something to get a new code. But if you look at it, if I'm creating a new function, the function app settings, I'm not going to go into detail on this, but I just picked up out of the box. When you create a new function, you can actually choose what your trigger is, like HTTP trigger or timer, Azure storage, blob storage is added to a specific container. So you can have this. This is one way of doing it, or you would use your event grid, which then triggers this function. Or if you want to send an email, so this is the out-of-the-box thing that Nimisha was talking about. So the send grid is already there out of the box. It's created something for you. Or this trigger actually has the code to look into a blob, and then, but then you have to do what it does with that. So all it does is it'll look at the blob and see when that changes. So you've got different triggers. The one that I've used is a HTTP trigger. That's why you've got a HTTP endpoint, which you hit, which is that endpoint, HTTP trigger 1. And it's called HTTP trigger 1 because I called it HTTP trigger 1. If I called it some other name, you would have seen some other name over there. So that's all with this demo. Unless you guys have any other questions, we can take it from there, or we can call it a day. Thank you.
Yeah, thanks a lot, Avi. It was really great. But I will log off now. Oh, you have a website of your own. Very nice. Thank you.
Thanks, Avi.
Okay. Okay then. Thank you guys. Sorry it took a bit too long.
Avi, very good one. Thank you very much.
Thanks a lot, Avi.
Thanks, guys.
Abhi,
Thanks, Abhi.
Yes.
Abhi, can you just share the recording?
Yes, I will do that. I'll share that.
Okay. Animesh, I think you just woke up from the sleep, yeah?